All right. Welcome back, everybody, to Live with Nassim. We are in July of 2022, July 6th. And wow, people are streaming in, 66 people, 69, 71, instantly through the field, becoming present here into this webinar with us. Great to have everybody coming in. Go ahead and put your hello into the chat like you're doing already, where you are from. Breton, France, Northern Arizona, White Rock, Canada, Yuma, Arizona, Wisconsin, Japan, Switzerland, Colorado, Canada, Florida, Germany. Wow, so great. We got the whole world beaming in, Nassim. We're always so grateful. Look at that. We've already just doubled what we had 30 seconds ago.
Yeah.
Almost 120 people here already. Well, there's a lot going on, a lot to discuss. So welcome everybody to the Live with Nassim. We're excited to be here with you and always so grateful that you join us in these monthly Q&As. And if you're new to the monthly Q&A and to the Resonance Academy, we welcome you. We really appreciate your participation and helping us to let other people know about what's happening with unified physics and what it means for our world. As you know, it's very dear to our hearts and minds, having dedicated Nassim's 30 plus years, and all of us here just pouring everything into what we can do to bring this into our world at this time, which is of course very timely. So this is a Q&A session. There are many questions already being posted here. And if you do want to add a question, there's a Q&A button at the bottom if you're new to this interface. So please put your questions there and put your comments in the chat as we go along. And be sure to set your chat so that everybody can see your posts rather than just panelists and hosts. So there's a setting at the bottom of your chat for who can see your posts. Your messages. So make sure that says everyone. And as you may have noticed, today we also have William Brown joining us, one of our faculty favorites. So that means that something interesting is up. You got William here as the pinch hitter on this one. There's something going to happen.
Lots happening. Yeah,
lots happening. Well, welcome both of you guys, and welcome Nassim. We're really grateful to have some time with you today. And just go ahead, Nassim, and say hi.
Yeah, and thanks, William, for being on. Yeah, we've been doing some cool biophysics, and I thought William be great to have on today, and so we can talk about these kind of things. We've been doing some really good work in physics as well. And I think that, yeah, it's really nice to be at this point for us, for me at least. Everything that I needed to see is there. So I'm finally in the phase of actually finalizing the paper. And that can take a few months because it's a large manuscript and there is a lot of references and so on. So the bibliography and everything is a big job. And so, but it's great to be in that phase. And awesome. And to be able to start paying more attention to the biophysics implications, of the theory. And so been discussing with William about all these things in the last few days, and with some physicists and biophysicists from external source as well. And it's really, really nice to see the reaction, and it's really exciting to see, to be in a place where I feel very, very solid. The theory feels really, really solid, and to bring it into biophysics is really exciting because you see the implications of it in the biophysical world and how it emerged, and it's really enlightening and profound to see that, you know, relationship be established very solidly from solid grounds. And a lot of it has to do with fluid dynamics and the you know, the way space-time collective behavior occurs, and you know, how they relate to the energy production at the biological scale, and the foundation of the self-coherent, you know, behavior of systems at the biological system emerging from collective behavior at the atomic and subatomic level. So that's, you know, very profound in terms of its implication to understanding, or at least a first step towards understanding the energy requirement for biological collective behaviors, but the as well the energy requirement for awareness or consciousness and so on. And so there's that part as well that's being worked on with Dr. Ines, and you know, that has been really exciting as well to see. So yeah, lots to discuss.
Excellent.
And it's so interesting because the bioenergy utilization in the cell, the process of extracting energy, using that energy for biosynthesis, and you know, doing all the various cellular functions, that's involving protons and electrons. You know, the cell is moving around subatomic particles. So, you know, having a unified physics solution of what is actually a proton, what is an electron, you know, the ability to, from first principles, compute its mass and see where the energy for nuclear binding forces are coming from, electromagnetic forces are coming from, that bind electrons and protons and bring them together to form molecules. Understanding that this is a coherent phase, a coherent structure of the Planck plasma and the fluid dynamics involved in that, you can get some really keen insights into the bioenergy of the cell. And for me, that's just been one of the most exciting things as we begin to explore, is seeing it, the process in a way that has never been conceptualized before. You know, it's like you can actually begin to understand the bioenergetics and the biophysics in terms of Planck plasma dynamic and fluid dynamics, fluid flow. It's very exciting.
Yeah, it's so great. And that Nassim, in recent faculty Q&As, William has given us a little hints here and there that there's some, not more than hints, because you pointed to some papers and things where there is some, you could say, theoretical corroboration of the foundation of the theory in some other research and theoretical proposals. Is that tied into what you were just saying about some of the other physicists that you're talking, biophysicists you're talking to, and some of that research that's corroborating?
Partly, yeah, partly, and as well, you know, unrelated, you know, publishings that are occurring right now, and findings, a lot of findings that are really supportive of the whole foundation.
Yeah, a lot of the predictions that we made in some of our, you know, previous work on the biophysics have been to put it lightly, strongly corroborated. I mean, if not directly observed and verified. I mean, some of the DNA change mutation mechanisms, how DNA changes can occur like a non-random fashion. That's been observed. It was a study that was published. The role of mitochondria in channeling light, acting as an optical waveguide and resonator. That's been recently observed and published. And there's a number of different things that have been strongly corroborated by experiments and observations recently.
Yeah, which were consequences of the, more first level approximation approach to, at the time, that now have a very, very solid foundation. And that's what really makes me giggle inside, because when you run these equations, it turns out that there's a significant amount of variables, and all of these have functions, like, for instance, the angular momentum, the circulation, the fluid dynamics, and so on, like the thermodynamics and all these that are fundamental to the work, so that you can predict mass and charge and electromagnetic effects and orbitals and all this stuff. And when you do these calculations, it all works out. And then when you apply it to scaling across the universe, it all works out. And so that you go from the Planck to the size of the universe, right? The observable universe, and you predict the temperature, for instance, and it happens to be right in the middle of all the current estimates, for the background temperature of the universe. And so there's many, implication that, like, for instance, the reason I'm mentioning that is that when you look at the biology, you can now have a direct conceptual view of how the energy is transferring across the scales, right? So the whole scaling relationship of the entropy in the universe, if you'd like, and you can put biology in the middle, where it belongs in the scaling, and find the correct values for this level of interaction, and these interaction, they represent as well information flow, right? You can think of it as information flow. In physics, energy and information are interchangeable, just like mass and energy, by the way. And that's why there's a clear relationship between information and mass. And you can think of mass as a certain level of information flow in a region of space. And you call it a particle, or you call it a planet or a star or a galaxy, or, you can think of it that way. And when you do, when you put the biology in the middle, all of a sudden you realize, the information rate is very high. And we tend to visualize biology as very slow moving thing, like we tend to like see biology in terms of the little movies that they fed us, throughout high school and university, of slow moving amoeba kind of thing that makes your body work. And it's far from the reality of the energy levels and the dynamics that are occurring. And these dynamics are not occurring in a vacuum. Pardon me the pun.
Yes, they are.
Yeah, they're occurring in fluids, right? In fluid dynamics. And so that's often overseen, overlooked. And these fluid dynamics are very, very important. And they actually, in the mitochondria example, are part of how the interaction is occurring at the electron and proton level, meaning like the chemistry of the changes where the electrons and the protons are separated, charge separation, if you'd like, in the fluid dynamics of it's literally running a little, motor that is spinning very, very fast, and so on. And it's actuating pumps as well that are pumping electrons across a boundary to produce charge separation. And it's doing that at a very, very high rate. It's not slow moving. There's nothing slow about it. Like you're actually looking at significant, high energy dynamics of, charge separation. How many of these little protons go across the pumping membrane?
Yeah, I mean, the numbers are really just remarkable. It's really hard to grasp, but I mean, in a second, under kind of, let's say, normal physiological conditions. So like you're sitting doing a live webinar, not doing a whole lot, so around 500,000 protons are going to be going through a single pump every second.
Every second.
A single pump every second.
Yes.
Yeah.
And the pump is pumping it as one proton at a time.
What?
Yeah. Right. So
where is it getting the protons from?
That is a really important consideration.
All right. So go ahead, tell us.
Yeah, so most of those protons are coming from the water in the mitochondria. Yeah. And so, the water in the cell, in the body, in most cases is not the normal kind of state of water that we're familiar with, that we think of, what's called the bulk phase of water. And that's the phase of water in which the water molecules are all kind of variously oriented and more or less randomly diffusing around in the cell, and especially in the mitochondria, the water is forming a very highly specific pattern of structure. And it's more liquid crystalline than purely in the liquid phase. And in this state, there are some remarkable properties that the water has that it doesn't exhibit in a normal kind of bulk phase. One of these is, the technical term for it is the protons become delocalized. That is, so, we're talking about H2O, so oxygen with 2 hydrogen molecules, atoms on it. Those hydrogen atoms become in a state where they're not specifically tied to any one oxygen. They can kind of freely move around. They can even jump from oxygen to oxygen, so they're kind of shared. And in this state, the protons, those hydrogen atoms, can very easily—
You should visualize, coherent vortices, kind of jumping around in a medium, in a fluid medium that is highly coherent, right?
And so those vortices, they can connect, form like tunnels, tubes, wormholes, if you will. And so actually, and this has been observed and measured in that liquid crystalline state of the water, those protons can jump so that they're not going from like point A to point B in like a linear fashion.
Mm.
You know, it's called quantum tunneling, you know, but if you actually, the fluid dynamics of what is actually occurring, it results in some really unique properties. One of which is that these protons can be very easily exchanged, donated, if you will. So they can be used from the water to drive catalysis, catalytic reactions, the enzymes. They can be driven through these pumps in the mitochondria, so much so that you can get up to 100, 500,000 protons a second going through these pumps. But
Yeah, it's something.
One pump. Yeah.
Wow,
but
great.
it's coming from the water.
Yeah.
And so, you know, the role that water is playing in the cellular system is highly significant, to put it lightly. Again, you know, it's not.
Well, that makes sense. That's such an abundant source of what's needed, proton-wise, to transfer that many per second. That would be the source.
Yeah, and that life, all life comes out of water, you know.
Yeah,
so
exactly.
You can't just ignore the water. It's actually the source of the coherent behavior.
And water is the closest thing we can observe directly to the dynamics of the Planck field, if I'm correct about that analogy.
Yeah, like hydrogen and oxygen, you know, absolutely.
Yeah. Mm-hmm.
And
those dynamics. Mm-hmm.
Yeah, and when you have the holographic solution in there, but more developed, that's what's published on right now, what's going to be published. You have all the thermodynamics and now you can look at the problem from the quantum field, meaning, you have fluid dynamic solutions that are occurring at the Planck scale that are producing the proton and the electron. And these fluid dynamics have scale relationships to the ones you're observing. And so you have a very clear path, mechanical path, to the biological dynamic and the exchange and the thermodynamic components and the information flow and so on. And so we're in the middle of calculating all this. It's remarkable. Yeah, and it's fun because it's so solid, and all of a sudden you see biology completely differently.
Yeah, sure. Yeah, absolutely. In a much more holistic.
Yeah. You can literally see biology as vortices in the structure of space at different scales, like starting with the proton. If you want to start with the proton, the collective behavior of the Plancks that makes the proton, which produce a collective behavior through frame dragging. And I mean that technically. I'm not saying this just loosely. True frame dragging is producing, collective behavior on the outside the electron that the proton that we call an electron, and produces the hydrogen atom in space. And from there, energy exchange with the vacuum and the dynamics of the collective behaviors changes, when you're going up in scales, so that you have more and more protons orbiting, electrons and protons orbiting each other, which is your table of elements, if you'd like. And the result is that they start these collective behavior of molecular interactions produce as well, biological collective behaviors at much larger scale, but that are energized or that are produced by the information that is coming from that lower scale. It's really, it's a really holistic view of
truly.
Yeah, it's very nice.
Cosmically holistic.
Yeah.
Yeah, right.
Yeah.
Spanning the whole breadth.
Yeah.
Great. That's a fantastic insight into the biophysics research. Thank you so much for that.
My pleasure.
You ready to transition into some questions?
Sure. Yeah. Let's get some.
There's a question here, and I was going to ask you a question, Nassim. There's a related question from Simon, who I'll bring on. But yesterday, the Large Hadron Collider was fired up again. Apparently, it's going to run continuously for 4 years now.
Yeah.
And they've upgraded systems. They're going to get many times the number of data points in the various test apparatus that they have, experimental apparatus that they have. And so, we'll see. They're hoping anyway to discover some new particles and forces and dynamics such as that. And one of the things that I've been seeing, which I don't think anybody here has asked about it, and it's kind of a bit more of the new age spiritual fringe, maybe fear, concern about this technology spinning up, creating a black hole, opening up portals to other dimensions, other parallel realities. And there's been a lot of talk about that.
These concerns are not only from the metaphysical community or the the accelerator was initially one of the possibility was Texas. It was refused. It was pushed back because of concerns about the production of mini black holes in the accelerator, and so there is concern from the standard views. They're not the majority views, however, but one could make an argument. I'm not so worried about that, since my theory predicts that everything's a black hole.
Right? So we got plenty of them around as it is.
There's plenty of them around, and the ones they're gonna produce are very unstable. They only last like billionths of a second, right? And so they have various opinions. One of which I think that should be a concern that's not being considered very much is that you're producing large fields on a region of the surface of a planet, and you're continuously producing that on the surface, and to say that it has zero impact on the natural field of the planet is, I don't think, an accurate assessment. You can think of it of like, if I made a teeny accelerator and stuck it on your skin for at full power for 4 years, would it be good for your biological structure? But that's another story. But yes, I very important fundamental things may be found. In order for them to be understood, they will have to be understood in the context of the theory we just finished writing. The standard model was a good first approximation, and in it, perturbation theory and multiple things in the standard model, including the Heisenberg interpretation, need upgrade.
I see.
because there is a fluid dynamics solution to vacuum fluctuations at the quantum level that give a very clear mechanical, like, angular momentum, thermodynamic, entropic, description of physics that can be linked to the current standard model if you want to. It's just that, it was a first step approximation with certain tools that were used. And, now it's an upgrade on the tools, basically. In these tools, you have scaling functions that links up the dynamics at the quantum level with the larger dynamics of the self organizing universe. And so that connects quantum theory with relativity. And from these equations, in both cases, you can go back to the standard model, or you can go back to relativity, but you don't need them anymore because it's much more precise in this manner.
I see.
Yeah.
There's a related question I'm going to bring on Simon, who asked this question. I think I got the right remote panelist. There we go. There we go. I'll read this question because it's related, and it's of curious interest to understand a little bit better the relationship of the standard model and what they're finding to this.
Okay.
Hi there, Simon.
Hey, Simon.
It's good to see you again. Welcome.
We spoke before.
Yes, we have.
Yeah.
Can't forget that
background.
Thank you.
So Nassim is asking, I recently read of new discoveries of tetraquarks and pentaquarks by scientists at the Large Hadron Collider in Switzerland, and they claim the new structures exist for just 100,000th of a billionth of a second.
Right.
Well, may explain how our universe is formed. How reliable do you think this type of discovery is compared to what you are about to publish? Are you aware of this discovery claim, and how does this in any way relate to your unified field theories in the full manuscript you're to publish that you could share at this time?
Right.
The new discovery claims the pentaquark decays into particles that none of the others produce, while the two tetraquarks have the same mass, suggesting they may be the first known pair of exotic structures.
Right. Well, okay, so I don't know where to start with this. Or I could start many different places, but let's just start with the conceptual notion of an accelerator in the first place. So there's a very, very, very large assumption that's made when you build an accelerator to explore the quantum world of the subatomic particles. And that assumption is that if you take a Swiss watch and you smash it with a very, very, very large hammer into like many, many, many pieces, that the understanding of the pieces that you're finding are fundamental, meaning that they're part of what makes the thing that was a Swiss watch before, in such a way that the Swiss watch, each piece would be like its own entity, where if you smash a Swiss watch, you're gonna have pieces that are part of a gear and part of a shaft, and there's other pieces that are part of the shaft and the gear and all this. And after you've smashed it into billions of pieces, you might not be able to reconstruct what was the mechanism that actually made this work. And there's a circularity there, and I mean, I have pun intended, since accelerator is a big circle. That is that more you increase the energy at which you're breaking the thing, smaller the pieces you're getting, and smaller the pieces you're getting, more fundamental you think those pieces are. Meaning that, like, if I take two cars and I smash them together at 60 miles an hour, I'm gonna get I can calculate the approximate pieces that I'm gonna get from the car and how fast they're gonna fly out, you know, of the origin. And so the energy and so on. But if I, you know, have the two cars going at 300 miles an hour into each other, the pieces are going to be much smaller. It's going to smash differently, and the energy of the pieces that are going to go flying is going to be much higher. And you know, I can, you know, and so I'm giving a really crude, you know, description of an accelerator, but I'm just giving a general idea. Like, I mean, Feynman mentioned this problem, you know, others mentioned this problem. I'm not the only one pointing at it. You know, the further issue is that the standard model approximation, so when there's no fundamental core to the mechanics of the model, meaning, you know, the source of the strong force, QCD, QED, the source of the electromagnetic force, all this, that doesn't have a strong foundation, right? And so to assume that so imagine in the context of a holographic mass solution, you know, in the context of a unified field theory based on the Planck plasma oscillating in space, meaning spinning in space. Imagine that you're colliding two balls of billions of Plancks, you know, coherently spinning in space. You can imagine that as they hit, they're gonna throw Plancks everywhere in chunks, right? And you might think that these chunks are fundamental, you know, but I would challenge that by the mere fact that they're completely unstable. And so, and you know, any fundamental particle of the universe, right, would be stable like a proton, right? Which is extremely stable. We have not seen one proton decay since the Big Bang, the so-called Big Bang, right? So, so the, you know, so it's a path of exploration that teaches you things. So there's plenty of things you can learn from an accelerator that are really useful. For instance, the radius of the proton, you know, which my theory predicted correctly, and the standard model was off by 4%. And it's when the standard model correction, that is the theoretical part of the analysis of the data, the standard model correction was removed, that they got the right radius, right? So, you know, these are things that are very important and significant, because 4% in quantum theory is like another universe, right? It's non-trivial. Like most of quantum theories is measured with like 10 to the minus 10 to the minus 11, sometimes to the minus 13 accuracy, right? So 4% is like completely gone. It's nowhere close to that, right? So these kind of thing tells you that there's missing, you know, a fundamental understanding. And so the accelerator is really like something that can teach us about the forces better, and the relationship between the radii and have accuracy on certain radii. But when it gets to, I mean, basically, in order, like, you can continue to increase the speed, right? Get closer and closer to the speed of light. And eventually, you know, if you were to get to the speed of light, your accelerator would be a black hole. It's no coincidence, right? Like, meaning the amount of energy you would be producing in that region of space,
Yeah.
you know, to do that would require that you're a black hole, right? So and at that point, you would be probably finding the Planck oscillator, right? You would be finding Plancks, right? That and so the source of the self-organizing behavior of a proton is the Planck. There is sub, you know, structures. Like, you can have quarks, and however, they're part of a collective behavior that, you know, is stable at the proton level. It's extremely stable,
Okay.
right? Like, extremely.
And even within the standard model, the quarks only go so far to explain the fundamental particle of the proton, because they
Correct.
only,
There's a spinning problem where you
yeah,
need
they
billions
account
and
for
trillions of quarks.
2% of the spin, 2% of the mass.
Right.
The rest of the mass, you need quantum vacuum energy fluctuations.
Yes, correct. And you know, if you're generous, it's more thought to be about 4% of the mass, which happens to be the same at the cosmological scale, right? And yeah, 4% of the mass, the proton, and the rest is considered to be the strong force, which is, you know, the point I was making in my first paper. I called this word child proton, right? Is that couldn't be a coincidence that, you know, if you consider the strong force, the proton obeys the exact condition of a black hole. And you know, even for the standard mass, the proton, the standard theory does not account for the mass without using the strong force. It needs to use the strong force to account for the mass, even with a very small mass, you know, 10 minus 24 grams, I believe. So it's very and this is what the new paper clarifies. So the new paper clarifies that a little bit, I gotta watch what I say because it's not published, so I'm gonna be a little cryptic, but a little bit like in string theory, gravity can be extremely strong, but it's wrapped in very small dimensions. So it's not experienced, you know, it's experienced as very weak away from these dimensions, these very small dimensions, which is like a way of visualizing it that is it's correct, it's okay, but if you don't have a good definition of dimensions, you might get confused about what you're looking at. And that's how string theory got confused, because you can get lost in dimensions and then you don't actually understand the physics that you're actually experiencing or seeing, right? So in this new view, then gravity, let's just say there's a shielding effect, okay, that makes it so that that gravity is experienced as weak, very, 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 very close to the event horizon of a black hole, right? But very strong at the horizon or close to the horizon. And that relationship between those two curves, the very highly, you know, hyper exponential drop, and then the 1 over r is a phase transition in the Planck collective behaviors. And so all of a sudden, you know, the force and the mechanics of the fluid dynamics of spacetimes are connected. And as soon as you do that, then you get a clear picture of the way the proton self-sustain, because in all of physics currently, there is no source. There's zero source, meaning there's no source for mass, there's no source for the electromagnetic field, there's no source for the Big Bang. There's a very large violation of conservation laws, which are the ones that they hold the most sacred. So and this is why quantum theory had to get so weird, by the way. It's because you had to have diffusion equations that don't diffuse. You had to have all this really weird shit that happens that they call quantum weirdness, right? That actually, if you understand in terms of fluid dynamics, like pilot wave theory, for instance, for the double slit experiment, then all of a sudden, it all starts to make sense. And it's not so weird. It's just the dynamics of creation, And then accelerators are not necessarily required. They would be built differently. Instead of burning energy, they would be making energy, right?
Yeah.
Because that's another cost to humanity that people are not discussing so much, is the cost of like having super conductive magnets and coils, going for 4 years at full power.
Mm-hmm.
And the energetic cost of this is
Crazy,
mind-boggling.
Yeah, and not very productive in the end.
Well,
For them.
I want to make clear, I'm not criticizing. In terms of like, it got us to where we are, and we've learned a lot. And the radius of the proton measurement was really important. And it was
in that regard, of course.
Yeah.
Mm-hmm.
Yeah. So when the instrument is used in the context of a complete theory, it makes sense. And as well, at one point it has a limitation, and it's like no longer needed to continue to try to push the boundary, because you understand the dynamics. You don't need to go and measure a Planck, because you won't be able to. You're gonna be
I need a little tiny ruler.
Yes. Yes, very teeny dimension.
Very tiny.
And so I mean, you want to make mini black holes, okay, well then maybe you use something a little different than what an accelerator looks like nowadays.
Right.
You might not want to collide things, but actually get them to cohere, right?
Right. Yes, the whole
now I'm saying
reversal of the approach.
Already.
Okay, good. We'll leave it at that.
Yeah, we'll leave it at
All
that.
right. Any comments, Simon?
Well, thank you. Well, yeah, you did a very well illustration of what the difference between a Planck and a quark is, which is what, as a non-physicist, I was trying to get my head around. And I believe that's what you did in terms of like the smashing of what that device does. And I remember watching your lectures about that and the radius of the proton, and how you talked about, I may not get it right, but that that you're not going to get that accurate after it's been smashed, like you were just talking about in terms of the watch.
Right.
So that fully answers my question. I appreciate that. I was curious.
Thank you.
When you publish your papers, your manuscripts, your team, is it considered I don't know if this is the right question. Is it considered theoretical physics, experimental physics? Is that right? Or is that not the distinction that's made?
It's
Like when I
considered
talk about it
theoretical
with my
physics.
friends, I should say, is it theoretical physics like Einstein had, and then it was experimented and proven, or how would
Right.
you?
It's theoretical physics.
Okay.
It's just that it's a very strange theoretical physics in the sense that it's theoretical physics that is able to predict most of the constants of physics, well, all of the ones we've looked at so far, and the forces. So it's very strongly validated by current experiment with high precision, right? So it predicts values that have 10 to 11 digit accuracy after the period, and it nails them. But which is remarkable for any theory, for any theory that you would have at least one constant that you're nailing like this would be really, really good. But when it nails all of them, then that's
You're onto something.
yeah, onto something. Just say that. And that the variables cannot move, by even like the 11 digit, at all, in order for everything to it's just like cemented. You can't go anywhere. You can't do anything about it. It's just that, right? And so,
Yeah, great.
is it still theoretical? I don't know. Maybe we need a new word.
Yeah, there you go. Exactly.
It's not experimental in terms that you're building something, but you can build something from it, like a whole universe. So,
Great. All right. Well, let's leave it at that for right now.
Yeah.
Good. Thank you,
Work
Simon.
that out for your team to develop a new word for that, for sure.
Yeah.
Yeah.
Will do. All right. Thank you, Simon.
Yes.
Take care.
Thank you, Simon.
Take care.
Have a
Bye-bye.
good one.
Thank you.
Yeah, I took some time on this question because a lot of people are asking.
Yeah, definitely.
And I really, really want to make the point that, this kind of experiment have positive impact as well. It's not all, it's part of our evolution. I hope that, we will get some clarity on this as we, get to understand this deeper theory,
Great.
Yeah.
Great. Nassim, I'm going to bring on a woman named Liana Silva, who has interesting research she's doing in relationship to some known companies, and she wanted to ask you some questions because she's using the holographic mass theory in the research that's being done.
Okay.
And it's a little bit long for me to read that, so I'm going to bring Liana on to say hello and maybe provide a little context and ask her question.
Hi, Liana.
How are you?
Hi, we've talked before.
Yes, we have. How are you doing?
Good, and you?
Good. It's so nice to see you.
Good to see you. You were working on your master's or your PhD? I can't remember.
So right now I'm actually finishing up my bachelor's.
Okay.
Yeah.
Oh, good.
Yeah. In biomedical technology. So.
Okay.
But
Perfect.
More about consciousness, specifically, and trying to get people more aware about consciousness on a metaphysical and a physical aspect, and kind of defining it through the laws and languages of our own culture and our own histories, to describe what is life force and spirit and consciousness. So that's what my company is trying to do. And I'm just so happy to see you, because a lot of my work has been inspired specifically on your papers. And we're creating a bioprinter right now using plasma-like technology. Yep. So kind of free energy, or zero point energy system, but it's the idea of doing it and creating it as a biological means. So proving at a biological level consciousness and unity consciousness.
Wow.
Also testing as well behaviors, right? So we could possibly even test with this plasma-like energy the feedback frequencies that it gives.
Right.
And then also testing what does it mean to be a conscious human being, and what does it mean to spread conscious awareness to others, and how does that interact with the space and how we're interacting with each other. So showing that love and unity is an actual, type
An
of
actual thing.
Yeah.
And it demands some efforts.
It does.
Yeah.
Dan Winter. Have you heard of Dan Winter before?
Of course, we've known each other for 30 years or something.
I just started researching, trying to collaborate more about what he's doing and trying to bring it all together in some way.
Okay.
That's another thing I'm trying to look into. But my question mostly is, so my science is mostly about the natural ways that we can heal the body, right? So, and also the natural ways we could possibly create a neuron instead of AI technology, right? As we all know, AI technology, Elon Musk is creating this like brain, yeah, I love this smile, this brain chip, right? Crazy to me, right? That we're trusting as humans, we're trusting to put a brain chip, which is, humans are known for order and chaos, and what we create, right, has an unconscious energy. So I am trying to prove that AI in some sort is a unconscious energy, and that putting it in your brain, right, can feed unconscious, subconscious energies that maybe we're not aware of in this reality. So we need to stop that spread. In order to do that, we need to, provide a more biological, natural means to create a neuron or create, 0 point energy devices that are similar. So instead of using binary systems, now we're actually seeing reality as truly what it is, and then creating a, more of a quantum system. And quantum computing, as Google just came out with a new crystal computing. If anyone's seen that, it's kind of crazy. So that's my question. Is water also water and sodium, the geometric state of sodium in water? Does that have any correlation to consciousness specifically? That's my first question. Then my second question is this science important when it comes to the holographic field equation theory, and also just the state of unified consciousness? Is this important to stop that spread of AI technology so that we could study more natural ways to heal the body? Those are my two questions.
Okay. Those are good questions.
Thank you.
Yeah. It's cool what you're doing. I might be able to help,
I would love that. I emailed and asked. I wanted to hopefully get in touch with you because I have a lot of research ideas and projects that I have that are in tune with your science that I think that we could actually do together, specifically 0 point energy devices that are biologically natural.
Okay. Yeah, well, these equations I was talking with William about are part of us, doing that link. AI and integrated technology into, with people. Well, first of all, artificial intelligence, I think, is a misnomer. There's nothing artificial about intelligence. So
yes.
So I already have kind of an issue with the idea, but as well, I think that there's a very high level of overestimation of what AI is able to do and how fast it's going to get to anything else. And all experts, if they're honest, would agree with me right now, right? Like we're far from doing anything that resembles the behavior of an ant, which is much more complex, much more organized, so forget, anyway, so, but the other thing is that the integration of technology with the human is already done, right? Like you have cell phones, you have devices, you have all kinds of things you're using
Realm
already.
creation, right?
Yeah. And so the idea is that from where we're coming from is that we want to make that interface more fundamental, like less disruptive, you know, so that it's more of an extension of you.
Right.
So that it's not so, the interface is much more fundamental. And what I mean by that is you're talking about neurons, for instance, you know, we could link the neural activity of the brain with the technology if the technology is using the same field of information, right?
Yes.
So then you can have like a symbiotic relationship with the technology, so that the technology is not destructive but actually is generative of, you know, the field organization, so that you basically amplify your collective capacity. And that leads to energy production, gravity control, and all these things. So they're not separate. And I think that in that case, AI, well, it's no longer artificial. It's just an extension, right? Because
Right.
artificial assumes that there's a separation between things. There's no such thing. You know, you could think of us as a device of the universe, for instance. You know, that's the way I see this. So, you know, I'm just blabbing about what you were saying, but
Okay, I like
I'm
it.
trying to answer. I'm sure that William has good comments on this as well.
Yeah, yeah. You know, in terms of like the brain to machine interface, and particularly the approach taken by Elon Musk,
Right, yeah.
there's, you know, serious issues around, you know, whether you want to put a man-made electronic device in your body, much less your brain.
Right, it's the fact he bought Twitter too, he's trying to buy Twitter for me, that alarms me as well, right? Because we have phones, right, that are all interconnected. We're all using this binary system, this fake reality we all created for ourselves, right? That has it has an order for destruction, it has an order, you know, for chaos and order, right? But we want to put this in our brain and have them, at the hive mind. I swear, it's like,
well, but you know, so you know, even kind of at face value, it's doesn't seem like the greatest idea to me. But then also, though, if you consider that
it's a first level approximation of symbiosis, you know, it should not, you know, be the main approach. Like field interaction is much less abrasive.
And see that's actually one of the key points, is that it's based on an erroneous model of intelligence and consciousness.
yes,
Because it's based on the neurocomputational model. You know, this idea that intelligence and human consciousness, or intelligence even in mammalian species, more generally speaking, is emerging from digital binary type interactions of single neurons. And it's just remarkable that this is such a prevalent theory, because it's known to be incorrect.
right. And my thing is, to me, it's very ego based, right? When we're talking about that, we think we know what consciousness is, but consciousness was given to us. We didn't create it. So therefore, like, let's step aside our ego, right? And focus on that point, you know, that 99.999% 9% of reality, which is a type of conscious energy, that is creating all things, right? So once we can, as a scientific community, right, and this is what I do, I go around to universities in the United States, and I go to Gateway, currently talking to, you know, GE, you know, these high Boston Scientific, these people that, you know, taking their ego aside and saying, hey, there's a huge portion of reality that you're not seeing. And we've spent like what, hundreds of years studying the material science, but the material science is only a part of the truth of reality. So if we're going to continue to put material
Wait,
science,
I'll give you an argument.
yes, okay, yes, I like
Okay.
it.
It's nice to have put all of our efforts in the material science. It would be good that there is a appropriate definition of what material is,
Right.
which is
Redefining it
currently lacking.
consciously.
Yes.
Yeah, a redefinition of the universe, right? Because what is the universe, right? Like as you said,
Is it
if
the
we're
stuff
not
in it?
constantly questioning it, right?
Right. So
I mean, if we were all, this is my thing, if we were all really, for example, if that space and void didn't have a conscious energy, we would just be all one big blob of the same thing.
yeah, we're kind of blobby, but
Here we
yes,
are.
I understand what you mean. Yes. Well, you know, the thing is I'm very careful with the word consciousness because I like to use awareness better, and because awareness implies that there's information flow, and as well, you know, saying it's all consciousness has become popular amongst, you know, certain, you know, levels of you know, researchers, like some researchers, mostly that are in doing, you know, a lot of you know, exploration and consciousness and all this. But if you don't define what consciousness is, you just transferred, you could have said God did it, or you could have, you know, if there's no physics behind it, if you don't understand the mechanics, how it functioned, how it produced you, then you just made another dogma, you know. So it's really important for me that we understand the basis, and that's why I've dedicated so much time. And I think we're finally there, and that's very exciting. I mean, there's much more to be done, but the bases seem to work out, so it's really, really exciting.
And I just want to thank you for all the work you've done. Yeah, I honestly wouldn't have been in. I started writing or doing my research actually specifically because I had my own supernatural experience where I wanted a new beginning for myself, and I painted it. And I painted a mountain, and I said, what must start a light must end burning a flame. And my apartment burned down 2 weeks later. I lost everything I owned. Yeah, this really happened to me. I had a complete metaphysical experience. And then I started researching about this happening, and you came up, and I was like, holy crap, I need to like study this, because this is like something that needs to be, you know, people need to realize the power of their own mind. And when you have the power of
what you think and you say, yeah.
And it happened to me. And it was
remarkable
experience.
Yeah.
So
well,
great.
Everything.
Yep.
Thank
So
you so much, Liana. Thank you for
Keep
stimulating some really good questions and doing the research you're doing. It's fantastic.
Yeah. Keep going at it.
Yes.
Go hard. Yeah.
And keep us updated.
Need your help.
Trying to take the torch, you know, and keep it along.
Great.
Keep the fire going, you know. Yeah.
We appreciate it. We appreciate that. All right.
Thank you so much,
Thanks for joining us today. Be well. Bye-bye. Good to see that that level of extending the theory into some new research is happening.
Yeah, for sure. Yeah, it's exciting to see like what people, you know, how they take it and what they do with it is, I mean, it's amazing. I'm so excited to see what this next tranche is gonna bring in.
Hmm. Let's see, we have, what do we have? About 20 minutes left here today. There's a question that I'm curious to hear you answer, and I'm sure, I think you can do somewhat briefly. It's an anonymous attendee asking, how do you define scalar energy and what is its potential for healing?
Okay. Yeah, I mean, scalar energy, it depends how it's meant. If it's meant technically, then, you know, let's just say that there's a component to Maxwell's equations that are that have a scalar component, you know, and that component actually relates in well, I don't want to say too much, so but I'm gonna stop. Okay. It relates to the gravitational field in terms of like a scalar dynamic of the electromagnetic oscillation of the Planck field. So, and so it really depends if you're talking about, you know, the esoteric use of the word scalar is, you know, then that's something else, and it's vastly mistaken in many cases.
So in the physics then, in Maxwell's equations and the scalar component, is it basically just referring to how the field is literally just
it's propagating
across scale
space? Yeah.
So is there an actual wave function that is, I mean, the wave is propagating, of course.
It's a scalar, it's not a wave.
Yeah, that's why I know that's often called a scalar wave, but that's where it gets confusing.
Yeah, it shouldn't be called a scalar wave.
And so it's really more like, as with any scale, there are demarcations of the dimension, literally dimension, you know, larger, smaller, whatever, faster, slower. That's the scalar component.
There's a nonlinear propagation of the field, you know, which you know emerged in Maxwell's equation when it was pointed out by Feynman, but more in the sense that there's a problem in an electrical circuit that is not so clear to most engineers, and that is that the charge is not going through the wire; it's going through the space. It's not conserved in the equation in terms of thermodynamics, and Feynman pointed it out, meaning that it doesn't add up. Like there's a problem if you, until you consider the collective behavior of the oscillators. So it kind of forces you to take that scalar component. And you know, I could give much more details there, but like basically you cannot so there's a longitudinal component, not just a transverse component. And so for instance, and there's actually a great Veritasium on that got a lot of publicity, because he explained this problem, you know, in Maxwell's equation, in a circuit, in which, you know, you have a very long circuit with a switch on one side and a light bulb on the other, and the field mathematics don't tell you that the charge is going across the whole wire and back to the light bulb. It says that the charge is going directly to the light bulb from the switch. And so or from the power source, the battery, if you like. And so, you know, this component is not well understood. And it is this component that is related to the gravitational field when you unify physics, which we did. So that's why I can't talk about it too much, but there is lots of really solid stuff behind me just saying that it's the gravitational field. But one part is that, you know, biology is an expression of that same dynamic, that same scalar component, you know, because you can't separate it from electric fields and electromagnetic interactions. And that's happening in the biological entity, you know, it's actually the source of the energy for the whole thing. So, you know, if you understand how to affect scalar components, you know, in a proper way, you can create a resonant link to the biology and increase the energy level, for instance, in certain area or others. It's just how you're producing the field is really, really important.
We were talking recently about Dr. Sandra Michael and her, what she calls the EE system. And in the video interview I watched of her, she's describing it's using the scalar component and creating this phase conjugation of the photons that then resonate with the biological. And in and of itself, it's not doing any healing. It's just providing that energy resonance. Then the body will naturally do what it's prone to do, which is to restore its balance and so-called heal itself.
Yeah. The problem is a problem of measurement. Okay. And the problem of understanding theory appropriately, because this in terms, when I say the problem, is meaning like how the mainstream community will understand, you know, that the scalar component, how it functions and what effects it has and how you can utilize it. And it's because our devices are not set up because of this omission, you know, to actually measure well, you know, unless you're using, you know, very exotic devices, we'll call them, to measure well the scalar component of things, right? So, so since it's not measured easily, it's not utilized or considered very much, you know, and that's why in engineering they basically ignore the field completely and just, you know, go with models that are adequate if you're trying to do a circuit, you know, that's not trying to interact with the rest of the universe, right? That's just doing what you want in getting a light to light up, you know. You can actually just use, you know, the approximation that says that you can think of the electrons going down the wires. So the other thing is, but when you do that, then you're missing a part of the science, and you're missing out on a really important part of producing circuits that are trying to be in resonance with the rest of the universe, you know, to produce effects that are very useful for humanity, you know.
Great. William, did you have a comment? Because it looked like you were about to.
Yeah, you know, I was thinking about a related question on, it was asked, so is energy in the mitochondria, is this chemical energy or something else? And, you know, I was just thinking about that. just that, what do we mean by chemical energy? Because that is molecules exchanging electrons and protons.
Yeah.
And that is an electromagnetic field interaction. So, in the mitochondria, sure, it's using chemicals, molecules, biomolecules, fats and sugars as well, to generate electrochemical potentials, electrical field dynamics, potentials. You can think of it moving charges around much like in an electronic circuit. But, as Nassim was saying, in the electronic circuit, the energy is being channeled, if you will, or moved from the field, not necessarily in the wires. And so there's a similar situation in the mitochondria, in the cellular system, where you have movement of protons and electrons that are the charge carriers. The energy, again, is coming through the field.
Right.
So, yeah. So it does require a little bit of a different kind of way to view these dynamics, the energetics.
The really field dynamics.
Because actually, if you follow these equations correctly, the electrons, for instance, in the wires are not moving hardly at all. They're oscillating, but they're not going down the wire at all, right?
Yeah. Yep.
So
it's really good.
Yeah.
Is it, would it be accurate to conceive of the scalar component as you have this propagation of the energy, and within the field that is propagating through, there are basically kind of standing wave pattern of resonant points that would be that scalar component?
Yeah, you can think of it as of it as like producing vorticity in the space, along a path, so that there's not think of it like a boat, going through the water, or a particle going through a fluid producing a field, around it, one being charge, and then one being the electromagnetic component of the water moving as the particle is moving through the space, So this is a really simplified approximation that
but it helps to illustrate it.
Yeah.
Okay, great.
Somebody commented, so what are the wires for? And actually, you don't necessarily need the wires. I mean, there's wireless energy transmission.
Tesla figured that out a while ago.
Yeah, Tesla, was trying to set up you just transmit the energy through the field.
Apparently, the Coram brothers in Texas have recreated that.
Oh yeah,
Foster Gamble just did a recent show with a man named George Wentz, and they went down there and met with the Coram brothers, and apparently it's ready to go. So
yeah, well, I've seen it demonstrated on shorter distances, with small device, maybe like small device with maybe 10 meters, 15 meters between them transmitting power, but it's not standard transmission, far from it.
Sure.
But you can think of the wire as as like a conduit, that directs the field, that meaning that the whole thing has to be a circuit, but that doesn't mean that the energy is going through the wire, right? The energy can jump you know, because it's in the field, right?
The wire is just pointing out to the
Where to
energy
go.
source.
Right,
Bring the energy here.
right,
Yeah. Wow. Interesting. Amazing.
right.
Such a different way of looking at it.
Yes, and that's
Well-
why it's you know, Feynman pointed it out, and then and as he give that lecture, you know, he was making comments like our crazy theory says, you know, you know, that it's not in the wire, and
Not so crazy after all.
yeah, well, no, it's just if you don't have the mechanic, you see,
Right.
when Maxwell wrote these equations, he was thinking of an ether permeating everything, so that he had the field, right?
Right.
Which we later removed. So
Right.
without the field, it's very hard to visualize how this is happening.
That's right.
Right.
It's
And
just
that's
going
why-
down the wire.
Yeah, and that's why it's easier to abstract that it's going down the wire. If you make the math work, everybody can make a circuit, right? But the truth is that it's not doing that. And you know, and if you put the ether back in, or vacuum fluctuation, more modern term, you know, then it makes sense again.
Yeah. Well, I think we're going to wrap up. And Nassim, I wanted to see if you wanted to mention, make any comments, talk about the Egypt trip in the fall before,
yeah.
before we
Oh,
do so.
I'm so excited to do that. Ooh, that's gonna be so fun. We're gonna have an amazing journey, like usual. Tulum, the last adventure was remarkable. It was an amazing group, and I really look forward to the Egypt trip. We're gonna be doing everything with many, you know, special permission and so on, and we're really gonna be able to like have very important moment in very powerful places, and I'm really excited to be able to do that, especially at this time in history where humanity is needing the most support and encouragement. And if we can actually help cohere the field a little more, you know, I'm excited to be able to do that with a group of, you know, individuals. And like the groups are always so amazing. You know, what every person contributes is so important. And you know, and I always love to see the transformation that occurs for everybody during those things. You know?
Absolutely.
Yeah.
Yeah. Well, it's going to be fantastic, no doubt. And the special access permissions always just take it over the top for the experience that you're not going to get anywhere else.
Yeah.
So
Yeah. And
definitely jump on board if you're ready to have a trip of a lifetime in Egypt.
yeah, it's gonna
That
be
is
amazing.
for sure.
Okay.
Great. Well, I'm gonna have to wrap up. I actually have a massive thunderstorm about to hit, and I'm
Okay.
gonna run and close windows in the house. I can hear it like right outside the door.
Oh, yeah, you're on the East Coast, right?
I am. Yeah,
Yeah,
it's just
yes.
raging out there. I can hear it.
Okay, so we'll let you go. And
Yeah, I'll go, and we're wrapping up anyway. It's an hour and a
Yeah.
half, and you guys gotta get that paper done. So go back to work.
yes, I'm going hard. It's on the way. I know it's been
All
a
right.
long run, but it's on the way.
Thank you, everybody, today. As usual, we apologize for getting to a fraction of your questions. We had a lot today, but we love your being here. We really appreciate you guys showing up. Spread the word, let other people know to come into the Academy and take our course. And this will continue down the path of making this good shift in our world. So everybody
Thank
take
you,
care.
everyone.
Nassim, thank you today for all
Thank
your
you,
input.
William.
Thank
William,
you, everyone.
great to have you here. And we'll see you in a month for Live with Nassim in
Thank
August.
you.
Okay, bye for now.
Bye.
Bye, everybody.